So with a fecal transplant, you're basically taking poop from one
Yes.
person and you're giving it to another.
Correct. It's a messy business.
Dr. Sabine Hazan is an expert in the field of gut health and microbiome research. Her book, Let's Talk SHIT, is an easy-to-digest explanation of the human microbiome.
The future is in poop. The importance of gut health, which is really your immunity, is in the gut.
In this episode, she breaks down the FDA's recent approval of the use of fecal transplants for research into the treatment of autism.
It's going to be an important study to give us data onto whether siblings that are neurotypical can be a good donor for the kid that's autistic.
We also discuss the relationship between the COVID-19 spike protein and the microbiome, how people who got severe COVID lack a certain critical gut bacteria, and the need for precise microbiome research to develop effective treatments.
If anything we've learned from COVID is the importance of microbes that can kill us, but also microbes that can save us.
This is American Thought Leaders, and I'm Yanya Kellick. Dr. Sabine Hazan, such a pleasure to have you back on American Thought Leaders.
Thank you. Thank you for having me.
So there's some news hot off the presses, very relevant to your work. We have the FDA approving familial fecal transplants for research purposes. I mean, this is kind of a game changer. And the only reason I know it's a game changer is because we've talked in the past and have kept talking. And the other thing is you have this study where you helped some twins, severely autistic twins, get better. And so I want to talk about both these things and then the whole bigger picture.
Yes.
But what's going on with this FDA approval now? How is that going to change everything?
It's going to at least allow us to do the proper research. This is not a pharmaceutical product. This is using the stools of a healthy sibling into a kid that is autistic. And it is also looking at if the kid that is neurotypical has the same microbes of the kid that has autism, and therefore kind of decide, do we want to use that or not? So this is going to be a research that's going to give us some answers onto autism, hopefully, and also a research that's going to allow us to say, why isn't it working if it's not working? Why is one kid neurotypical and the other one is autistic? To be able to compare it, because kids share microbes, families share microbes. And so that's kind of like, what I want to see with this study.
Well, so let's break all this down, okay? There's multiple elements here. Autism, it's this multifactorial disease as best as I understand it at the moment. And of course, there's the HHS has this deep interest in tackling it because the rates have been going up, and that's kind of, I guess, incontrovertible at this point. The question is why, and this directly targets that. The other part that I think you're speaking to here is that people are different, and sort of one-size-fits-all policies for medical care just don't work. And this is one of the lessons we had during the pandemic, that you need to treat you look at each patient individually when it comes to microbiome, when it comes to their genetics, all sorts of things. So let's unpack all this for me.
Yeah. So, I think to unpack it, you kind of have to go back to the history of what happened, right? How did we get to this? What is the microbiome? How does FDA look at the microbiome, et cetera? So if you think about the microbiome, it's basically microbes in your gut, right? We describe the microbiome of the gut, but there's microbes all around us. If anything we've learned from COVID is the importance of microbes that can kill us, but also microbes that can save us. And the importance of gut health, which is really your immunity, is in the gut. So that's the first thing. When we embarked on this, when I embarked on this, I started, looking at fecal transplant because I come from a world of having done hundreds of clinical trials for pharma. And clinical trials for pharma basically brought me to the world of C. diff. C. diff, a bacteria that causes diarrhea to patients. They overdo it with the antibiotics and then eventually acquire this bacteria that secretes toxins and then gives them diarrhea and could kill them. And so when you look at C. diff, And you start in 1957 with Dr. Einsman, who basically decided, I can't fix my patients with antibiotics. I can't seem to get rid of this bacteria. Let me do 2 enemas of poop of a healthy, so-called healthy person, right? Back then, we didn't even know what was a healthy microbiome. We still don't. We have some ideas, but we still don't have it as a guideline of what does a normal healthy microbiome look like. So when you look at Dr. Einsman, and he just took from a gut feeling, because that's what medicine is. It's an art, it's bravery, I'm going to take stools from a person, put it in another, and he fixed those 2 patients. That was the first case. Those were the first 2 cases. From there, Dr. Tom Barodi started looking at that and saying, wait a minute, there could be something there. And there could be something there for autism. There could be something there for Alzheimer's. There could be something there for other diseases. And he took it to the next level, but he tried to show it for C. diff. The way it works in medicine is you have doctors writing abstracts, and they publish them, and they present them at the American College of Gastro or at these meetings. And then you've got 18,000 young brains from all over the country gather, and they go around these posters and they start looking at the data. And so that data of Dr. Barodi attracted the attention of a few doctors. Colleen Kelly at Brown University, Neil Stolman, who's on the board of the American College of Gastro, Sahil Khanna, who's at Mayo Clinic, Zain Qassam, and basically Jessica Allegretti from Harvard. So all these young people were basically fascinated with poop, whether it's their gut instinct that there's something there or not. It was definitely interesting. For me, it started at a meeting probably about 2 decades ago, or 3 decades, I can't even remember. But Neil Stolman took me on a poster, and he said, the future is in poop. And I said, please don't make me play with that, because I like my colons to be clean, and I don't like to step into this. And sure enough, fast forward, I had a doctor that was dying of C. diff. I was the girl that was bringing drugs to market for pharma. I was the girl that was enrolling patients for clinical trials, and I was well known for C. diff. In fact, pharma called me the queen of C. diff, because I was really good at enrolling patients. And the way that I would enroll is I would call on my colleagues and say, look, before you do fecal transplant, give me this patient, let me try this new drug. It's, safer. It's basically FDA is watching. It's cleaner. You don't have to do testing on the stool donors. And so I started enrolling a lot of patients. And when a doctor could not be fixed with the treatment or couldn't be fixed with the clinical trial, I did fecal transplant, and that doctor survived. And that was the first for me to kind of say, wow, there's something to this, right? And, but I would still do fecal transplant only when the clinical trial would fail. Because to me, the simplest way is, look, you're getting paid by pharma to do a clinical trial, you do the trial doesn't work, you at least have a backup, and you could use the money that you made from pharma to test the patient's stools, you can treat the patient, because fecal transplant, colonoscopies are expensive, anesthesia is expensive, testing the stools of the donor is expensive. So this was not something that you could readily do. And so when fecal transplant started showing Alzheimer's improved in an N of 1 for me, that's when I really paid attention. And then it kind of became from there, the studies of Dr. Adams. Dr. Adams was working with Dr. Barodi. I started working with Dr. Barodi. We all kind of united as doctors that played with poop to understand the microbiome a little bit better. And, I didn't really believe feces could help autism. I had to see it with my own eyes. And so I had to do that N of 1 with the FDA.
So I just wanted to kind of break this down for the uninitiated, right?
Yes.
I mean, basically, so with a fecal transplant, you're basically taking poop from one person and you're giving it to another.
Correct. It's a messy business.
Right. It's a messy business, but you're taking sort of what you believe to be a healthy poop.
Right.
And you're giving it to someone who has a problem. And with C. diff, it was an obvious very clear problem, and that there's no drug that will help them. That's how it started. That's what you're saying,
That's
right?
that's what
Yeah,
it's
yeah.
basically. So the people that come to me are always the people that have tried seeing a lot of doctors, and they come to me for clinical trials. Whether it's for psoriasis, Alzheimer's, they come to join a clinical trials. So we look for clinicaltrials.gov, we find a trial, we contact the pharmaceutical company, we say, hey, we have a couple patients for you. Can we embark on the trial and test those patients? So those are the people that come to me. C. diff, they came to me because they didn't have the funds to pay for fecal transplant, or the county hospital was not able to pay, or for whatever reason. So that's where we are.
So explain that to me, though. So you were giving them a fecal transplant, or you were enrolling them in a trial, or both?
When I started for C. diff, I was treating patients, and if the treatment didn't work, I would enroll them in a clinical trial. So I had multiple clinical trials that I was doing at all times. So I've been doing clinical trials for pharma for decades. And so when C. diff clinical trial didn't work, I would use the funds to pay for fecal transplant to help the patient.
I see.
Yes.
Okay, I understand
Yes.
now. Okay,
Yes.
very good. And then with this N equals 1, meaning this one patient, you saw a marked improvement in one instance.
So when I was doing it for C. diff, the only way in America to do fecal transplant is for C. diff. So remember, from Dr. Einsman to now, it took 62 years for fecal transplant to be part of the guidelines, because it needed clinical trials. We needed, Zain Kassam to show the data that fecal transplant improves C. diff. From there, pharmaceutical companies started paying attention and saying, wait a minute, if it improves C. diff, maybe we can make a pill of poop for C. diff and bring it as a pharmaceutical trial. They would bring it to the FDA. The FDA would help them, together they would bring out a poop pill, essentially. So when you look at, from the beginning, those two enemas to where we are right now, where it's part of the guidelines, it's part of the guidelines as fecal transplant. It's not part of the guidelines as, well, I'm going to use the product from pharma. But it's 62 years have gone. So in this country, if you want to have fecal transplant for whatever condition, you want to try for Alzheimer's, you want to try for MS, for Parkinson's, you cannot do it unless you have C. diff. And so the guidelines are very clear on that.
Well, until now.
Well, no, still you need FDA involvement. So that case of N of 1, which most people, don't realize, took 3.5 years to get approved by the FDA. Of course, COVID was in the midst of all that, where the FDA said, hold off on fecal transplant because we discovered COVID in the stools, and therefore we could pass stools with COVID to the patient with the immunosuppressed or the autistic kid or whoever we use feces, right? My first N of 1 of fecal transplant was actually not for autism, but it was actually for metastatic mesothelioma. So this was a woman that was supposed to die within a week, and the family came and begged me to do fecal transplant, thinking that it could be a good adjunct to Keytruda. And I said, well, let me look at it, but it needs FDA. So that case was pre-COVID, and that took us 24 hours with the FDA to basically say, hey, no problem, go for it. But it was still, I had to argue with the FDA to say, look, this woman's dying. Frankly, if I show her how to blend her grandson's poop, you have no data. I'm giving you the data, and I'm willing to do it and watch her. Well, this woman, it improved her up to a certain point. I mean, she lived on, months and months when she should have died within a week. What we learned from that case was that not only did her appetite improve with the implant, she was craving her grandson's foods, and her appetite increased, her weight improved. So it was a great adjunct in a way, but it had to be done the right way, because the FDA was right. This is poop you're putting in an immunosuppressed patient. So the problem then happened is that she ended up being given antibiotics down the road, and that killed whatever I gave her in the transplant. So, but that was the beginning to say, this is a patient with terminal cancer that was supposed to die within a week, and she lived on months and months, maybe because we optimized the gut while we gave her a drug to kill the tumor or suppress the tumor. That's the direction I want to go with that. But from that to that N of 1 with autism, that was 2019, and we submitted the case, and then COVID came in the middle of it, and we had a hard time getting that approved because COVID was in the midst of it. Mm-hmm. So if I want this familial FMT that's approved right now is a breakthrough in a way, or not a breakthrough because we haven't done the research, but it's going to be an important study to give us data onto whether siblings that are neurotypical can be a good donor for the kid that's autistic.
Well, just as as you said, right? You simply couldn't do these studies before.
Couldn't
basically.
Do it. No. And what changed, I think this administration is a little bit more efficient in the processing of the paperwork. I'm the agent, and I thanked her. She was back and forth, like within 3 days gave me an answer. The last administration, we gave the protocol, we gave the paperwork in, it would take like a month before we got answers back. So I don't know if the politics change. I would hate to think politics have something to do with treating kids with autism, because kids with autism affects both the Democrats and the Republican and the independents. It affects all races, it affects all religions, it affects boys and girls. So, to make it a political agenda is really not okay. And so we need to kind of think, when you look at 1 in 12.5 boys in California have autism, you got to pay attention. You got to put all hands on deck and say, what are we doing here? How do we do it? And this is an amazing study because this is not a pharmaceutical study where, the price of the stock matters more than the price of a life. This is a physician-initiated IND, investigative new drug, that's basically, as a physician, I'm going to be looking at these kids, every single one of these kids, and say, why did it work in this kid? Why didn't it work in that kid? And what can I do to that kid that it didn't work? Because I'm not going to wait, for something else. This is where it happens. It happens on the front line of clinical trials, where as a physician, you have the courage to try different things. And there are definitely a lot of different avenues for autism, because there are different causes for autism. Like you said, it's most likely multifactorial. I'm focusing on the microbiome and an answer with fecal transplant, possibly. But what about the kid that doesn't have a microbiome abnormality and has a neurological primary? Or what about the kid that has a inflammatory bowel disease where his colonic mucosa is completely destroyed and we need to fix that before we start implanting microbes? What about the kid that has a connection between the brain and the gut? What about the kid that has a genetic problem? These are different ways to treat. So when you do clinical trials, and when I do clinical trials anyways, I do clinical trials for a pharmaceutical company to bring a product to market. The product either works or doesn't work, and then the FDA says, okay, Dr. Hazan, the product worked, we're going to bring it to market, even if the product only gives you 20% success. But what happens to the 80% that didn't succeed on that protocol? Who looks at that, right? So think about it. The pharmaceutical company, their job is, hey, let's bring the drug to market, let's make billions of money. But who's looking at the 80% that didn't succeed on the protocol? Nobody. This is going to be a great trial because it's going to allow me as a physician, with my hat of a physician that has done hundreds of clinical trials for pharma, to say, okay, well, familial fecal transplant didn't work. Let's look at this trial. Let's look at this trial. Let's look at this trial. And let's not give up on this kid. Much like what I did with C. diff, right? I would first start with the guidelines, which is you give antibiotics. And then if the guidelines didn't work, I would go to clinical trials because that's what was available. And I would say, let me try ABC trial. And then if that didn't work, I would go to fecal transplant. and fecal transplant, 99% of my patients improved with C. diff. So I think that's the same attitude that I'm going to take with autism. I'm going to try I'm going backwards now. I'm going with familial fecal transplant first. And if that doesn't work, then I'm going to go to the clinical trials, and then I'm going to go to whatever else is being used that has improved these kids. Unless there's things that, Dr. Richard Fryer has some amazing studies that he's seen some kids improve. We're testing the microbiome before and after because we want to see what is it in kids with autism that is improving and what's not improving.
We first met because you had been doing work around microbiome and COVID-19,
right?
The virus, and then also what happened after mRNA vaccination, and this had profound effects on the microbiome. And maybe you can kind of remind us of what you discovered,
yes,
and maybe sort of bring us to the current stage where
yeah.
we're at.
So remember, I was the girl that basically was doing clinical trials for pharma. And when COVID, and I was doing fecal transplant, and that N of 1 was in the process during COVID. And at the beginning of COVID, I looked at myself and I said, I have a portal with the FDA. I'm connected with all these brilliant minds, Dr. Barodi, Dr. Stolman, so many brilliant minds. And I'm a physician, and I'm a physician on the front line of clinical trials. Surely, I can figure out, and I own a genetic sequencing lab that's looking at the microbiome and COVID, and we have the possibility to look for COVID. The first thing that came to me during COVID was, I bet you it's in the stools. Why? Because we noticed when we were doing stool analysis that if you have a person that has a nasal congestion and is growing a microbe in the nose or in the sinuses, you will find that microbe in the sinuses. If you have a patient that has pneumonia, H influenza, you will see that H influenza in the stools. Or a person with a kidney stone, Klebsiella pneumonia, you will see that in the stools. People are shocked when I analyze their stools and they don't tell me they have a prostate problem. And I say, you have a prostate problem, don't you? And they're like, how do you know? Because I see the microbe that would be present in prostatitis in their stools. So think about the colon. What is the colon? The colon is where all the waste ends up, right? And so you've got 3 parts to the colon. You've got the part that goes backwards. The motion of the colon goes backwards. That's the cecum. And then you've got the transverse colon and the sigmoid, where basically the stools are just to be evacuated. It's the process of evacuation, okay? So when you think about what we do when we do fecal transplant, we transplant microbes of a healthy person and we put it in the cecum for the best results because it's backwards and it keeps it in there, right? The rest of the colon is really for evacuation of the toxins. So think about you ate a hamburger with E. coli. Too much E. coli, it's in your system. Your body's going to give you diarrhea because you're flushing out that microbe that's too much of, right? Same thing when you ate some rice that stayed over the counter and you have a bacteria called B. cereus. You're vomiting that. It's foreign to the body. It doesn't recognize it, so it says, get out of here, right? So to me, the first thought was, wait a minute, immunity is in the gut. I know that the colon is where everything's there. I bet you COVID is in the stools. So the first thing we did, the first samples that came to America, we were right there trying to collect the stools. So the first patients that had COVID that we intercepted, we already had their stools and we started working a pipeline. And I even called Scott Jackson at the time because he was part of my biome squad. He used to work for the National Institute of Standards. And I said, I bet you it's in the stools. And he started looking and getting his team at NIST to look at the septic tanks. And that was all the brilliant work that was done from NIST at the septic tank level. But we were at the clinical level. We were taking patients that had COVID, doing a nasal swab positive, and we were finding COVID in the stools. We found COVID in the stools in 100% of patients that were positive nasal swab. What we then ended up figuring out is COVID can persist in the stools. And what we also ended up figuring out was that Some people were asymptomatic and had COVID in their stools, but yet never had symptoms. What was the difference between those people? The difference was their bifidobacteria.
Well, I'm going to jump in because
Yes.
I remember early in COVID, there was some anecdotal evidence. I think it might have even been from Korea initially that people that are eating kimchi, a lot of kimchi,
yeah.
are doing well or not catching COVID. And then I heard something similar about sauerkraut,
Yes.
which made me want to eat kimchi and sauerkraut, of course.
Yes. So, yeah. So that was my question at the beginning, right? Those anecdotal studies like of kimchi and sauerkraut, because obviously you can talk to people that ate sauerkraut and still got COVID. What's different between that population? Why is one person eating sauerkraut and kimchi is fine and another person not, right? So that was my biggest question. The other question that question led to me wanting to test, first of all, families, right? So because I'm a big family person, like you find the answers in the family. Because we're all different, we all have a different microbiome. It's easier to compare within the families, right? So you could see, we published the first case of a family, which was basically the kid had COVID, the other three didn't have COVID, and yet they didn't wear masks, they ate the same foods, the mom was taking care of her kid face to face, never got COVID, her two other kids never got COVID. The main difference between those three and the kid that had COVID was the absence of bifidobacteria. Not only bifidobacteria, there's another bacteria called Faecalibacterium prausnitzii, and there's an increase in Bacteroides that happens and loss of diversity. So we noticed that, but we focused on bifidobacteria. Why did we focus on bifidobacteria? Remember, we had the clinical data of the microbiome before COVID. We were analyzing stools before COVID. So we knew babies had a lot of bifidobacteria. I always spill the beans and then somebody's listening somewhere else and then they do the research and publish, which is fine. When I talked at the first microbiome meeting, I was saying bifidobacteria, focus on the BIF. Why did I focus on bifidobacteria? Because if you look at the bottles of probiotics, you turn the bottle and it says bifidobacteria. Now, in the olden days, scientists could make an experiment like the discovery of penicillin, right? And where a scientist left his apple mildew next to a petri dish with a bacilli, and then the bacilli disappeared from the fungus of the apple, and there goes the discovery of penicillin, right? So in the olden days, you could say all these things. Now there's because everything is about market and patents and business, there's a lot of secrecy to research. There's a lot of data that we don't know. And sure enough, bifidobacteria is important in absorbing sugar. It's important in your metabolism. It's important in your energy drive. It's important in, making sure a person wakes up and, in the morning and goes to work and is effective, right? So bifidobacteria is really an important microbe, and it's that microbe that is present in newborns. So when you start looking at the bifidobacteria and you start looking at COVID, we noticed that 43 severe patients with COVID had zero bifidobacteria. I'm just going to focus on bifidobacteria, not the others, because there are some people that have zero bifidobacteria and never got COVID, because there are other microbes that came on that said, hey, bifidobacteria is low, I'm going to up this group of microbes to basically create a resilience, right? You think about your kids and that's something we don't really talk about, resilience, right? So you think about your kids that took a ton of antibiotics and they're fine. They don't have any problems. Why? Because their microbiome has adapted to increase other microbes to create that resilience, right? So again, when you look at the bifidobacteria in these 43 patients, zero, and then you look at your patients that were exposed but never got COVID, like that first family that I did, we noticed they had a lot of bifidobacteria. So bifidobacteria was really the beginning for me. It was like, I wonder if that's the microbe I need to focus to neutralize COVID, to suppress COVID. If I have a lot of good bifidobacteria, maybe I'll be fine during COVID, right? And then it became there was a study that there was I forget where it was, but some newspaper in India, it was a woman. She lived to 117 years old, and they found that it was because she had bifidobacteria in her gut. So there's, even on your longevity, the longer you retain that bifidobacteria, the better it is, right? And it's not a simple thing, because people are like, what should I take? Should I take this probiotic? Should I take? No, it's not that straightforward. You got to figure out what is killing your bifidobacteria and what's growing, right? It's like having a field that just burnt and you're trying to stop the fire and you're pouring gasoline and water and you expect to grow some fruit trees. It's not going to happen. You got to turn off the fire, stop the gasoline pouring, bring on the water, and then turn the earth, replant, and let it grow. It's the same thing in the microbiome. You're destroying a city. So when you destroy a city, expect complications from that, expect disease to happen. And so that's really my field, to demonstrate that once you destroy a key group of microbes, you start the disease process. So what we discovered, this bifidobacteria was really the beginning. It was the beginning, and then when we looked at that kid with an N of 1 of autism, that we got approval after, in the midst of COVID, and we discovered if I give him a neurotypical sibling that has a diversity, that has good resilient microbes, that have, allowed herself not to have autism, but yet the boy has autism, then that sibling might be the answer for that kid. And what we noticed with this sibling is that the kid had one group of microbes that the sibling didn't have. So we picked that sibling. We didn't pick the other ones because they had some of the same microbes as the kid with autism. Are they predisposed to going into autism? Who knows? But we picked that one sibling, and that one sibling became the donor. And what we discovered with that was that there was a refloralization. And the refloralization process is really an engraftment of microbes to mimic, to look like the sibling, to look like the donor. And one of the things we discovered was that bifidobacteria increasing. Now, whether it was because we suppressed that toxic bacteria and allowed the gut to kind of rest and give it diversity, and therefore the good bacteria starts flourishing. But that case was really the N of 1 that, first of all, made me say, I need to see more, because that was the miracle. I think what I saw during the pandemic was a bunch of miracles, From losing no one during the pandemic to still being standing, speaking to you today with all, the controversy in my research, because, here I am, the girl that brought vaccines to market. And because I showed data that the messenger RNA killed the bifidobacteria, now I'm an anti-vaxxer. So the controversy has stopped the movement of research and science. Mm-hmm. And again, we need to stop with the controversy and say, let's ask questions. That's what science is all about. Science is about asking questions and pushing that narrative and saying it's not the way it should be.
And if I may just jump in, you discovered that the spike protein reduces bifidobacteria.
Correct.
Really?
Correct. So what we discovered with the vaccine is that it did kill the bifidobacteria within a month, but it persisted in killing the bifidobacteria. People come to me every day with long COVID or and I take their history. And I go back and I say, so did you have COVID? Were you vaccinated? And they'll say, yes, I was vaccinated. And I'll say, were you vaccinated? Did you get COVID after the vaccine? They'll say, yes, doctor. And I'll ask, did you get COVID before the vaccine? They'll say, no, I was fine before the vaccine. And then you kind of have to start asking, did the vaccine kill their bifidobacteria? In other words, they were fine. They had bifidobacteria in them, and then they started fighting the virus, and they survived, and therefore created their own little immunity, right, in a way, because immunity is the ability to get a piece of the microbe so that it recognizes the next microbe in the future, right? So you have to kind of, in layman's term, you have to think of your body as a group of communities, group of gangs or communities in your gut, and there's one microbe that approaches, and there's some of them that resemble the microbe, and it's like, hey, you're part of the gang, you're part of the family, you're part of the community, come in, you're non-dangerous. But if you see a microbe that's a foreigner, the microbiome is on guard and saying, wait, foreigner, we don't want it, reject, autoimmune process occurs, right? So that's how I look at it anyways. I could be wrong, I could be right, but this is how I see the microbiome. So when you look at these patients and you say, the vaccine, you got the vaccine, you probably killed your bifidobacteria. Now your bifidobacteria is low, you got COVID. So now it's like a double whammy. You're killing more bifidobacteria. And so these people, what happens with the long COVID or these vaccine injured, it depends on the timing, because there are long COVID that never got vaccinated. They got spike injury. I think we need to rename all that to spike protein injury. You have to start thinking of, at what point did they kill their bifidobacteria? Because if you look at the long COVID or the vaccine injured, and we're coming out with data on that, zero bifidobacteria across the line. I mean, I've yet to find one person that is deemed long COVID or vaccine injured that has bifidobacteria. So if they have zero bifidobacteria, I know, because I've been dealing with this for 5 years now, it's very difficult once you've killed your microbiome to get back up. So these people are still at a state of loss of diversity, loss of immunity, poor immunity, and they're also at a state, remember, bifidobacteria is important in absorbing sugar. So they're not absorbing sugar. And that's one microbe that they've lost. What about the microbe that helps break down, calcium to get absorption of calcium? They've destroyed that as well. So they're not absorbing calcium. What do you think happens at the cellular level in the mitochondria when you lack sugar and you lack calcium? You're missing that energy, that Krebs cycle. Your mitochondria stops working. Therefore, the cell's not doing what it's supposed to do. Their energy level is down. So what happens in the microbiome level? Your good bacteria is down. Now you have space for bad microbes to come in. That's your anxious patients, the people that can't sleep, the people that are like, have your mast cell activation syndrome. So this is kind of like the process of how it happens. So long COVID is really a spike protein injury. But also, when you look at these cases, they have zero bifidobacteria, either from the treatment or the virus themselves or the spike protein. But also, some of them have remaining COVID in their stools. So we need to pay attention to that.
There were some problems also with sometimes there being endotoxin in the COVID genetic vaccines and so forth. So that would be another route that there could be damage and problems. So does that factor into what you've been looking at?
There's a lot of different factors. There was the study from Kevin McKernan and Philip Buckhalls that basically showed a contamination, SV40, right? That could be a possible mechanism on how the spike protein became how this vaccine became a bifidophage too. Did it stimulate, the ability to stimulate cancer cells, for example? We don't know. That's a whole new area.
So that's a third thing, right? There's the SV40, and then there's also the just the endotoxin.
Yeah, the E. coli and the plasmid.
The leftover, leftover E. coli cells and so forth. I don't know. And
then the nanoparticle too. The fact that it's able to get absorbed. This is
right. That it penetrates basically all membranes.
Correct.
Right? The lipid
so that makes it even more like the whole idea. The reason I stepped into the pandemic at the beginning was really because there were so many red flags. The messages on the media, the vaccine stays in the deltoid. Nothing stays in the deltoid. It's not like there's a little pocket there that's sterile. The muscles are connected to the nerves, are connected to the blood vessel. Everything's intertwined. You can't just put something in a blood vessel and expect it's going to just stay there. And again, the blood vessel supplies the muscle. So it's all, we've so divided in the medical field with different specialties that we forget that the gut is connected, by blood vessels, by nerves, by lymph nodes, by lymphatics. It all circulates. So we can't just think, well, it's a gut problem. No, it's a gut and a brain problem because they're connected. And it's not just a heart problem. They're connected. We're going to come out with, and you will see probably in 10 or 50 years from now, there will be a connection between cardiac disease and the microbiome. We will be possibly able to fix the heart by fixing the gut, because it all is connected. It all moves. All these viruses are passing, moving. The toxins of these microbes, bacteria, travel, So that's going to be the future.
Are you aware of cases where, we've been able to treat people with either vaccine injury or long COVID by fecal transplant?
That's something that I possibly would bring. Although I think, as I was pushing, there are other ways to fix, something that's going to be coming in the future. You always got to keep on top of the research, and research is a story that's untold. It's one experiment after another, and you discover one thing and you move on to another thing. And then others kind of bring in their opinion and validate, verify, and reproduce what you've done, right? That gets you to keep moving further. Look, this case of familial FMT is going to be amazing. But in the time that I spent trying to get that approved by the FDA, which was 5.5 years later of this protocol being approved, I had patients with autism that came to me. I had to do something. So there are things that you can, when you understand the microbiome, that you can do to kind of modulate. So the whole process of refloralization is not just I'm taking stools from a healthy donor and putting it into the person. It's really refloralization that I coined was bringing back the flora. However you bring back the flora. You've heard of cases, and I forgot who mentioned it, but Suramin, someone said Suramin cures autism. Well, there's no data on that. But I'm sure what happened is there was someone that took Suramin and their kid flipped and became improved. Did that Suramin help that kid for that particular, microbiome issue, right? There's other cases that said, well, and I'm very linked with the whole autism community, right? Because I pay attention to everything. One of the things was antifungals. Some parents swear by antifungals. There's a woman that wrote a book, and basically it's about how she improved her kid who was nonverbal autistic, and now the kid is working as an engineer somewhere, and basically graduated college, etc., but she gave him antifungal. Now, there's a lot of parents that listened to that case and tried antifungals, and their kid is still nonverbal. Why is that? Because that antifungal was probably the right solution for that kid's microbiome. Maybe he had too much fungus in his microbiome, and therefore the antifungal improved that. So everything we're doing, and I think that's where I'd like to see, and I'd like to work with this administration right now, to kind of guide us better by looking at the microbiome. Pay attention to the microbes. Pay attention to what we're doing before and after. Before you bring on a drug to market, see what it's doing to the microbiome, short-term and long-term. I think that's where I want to bring pharma. People have said, oh, I'm shaking the beehive of pharma. I'm the girl that brought drugs to market for pharma for almost 3 decades. And my sister has brought Harvoni and ivermectin to market for pharma. We're in the clinical trial business, my whole family. We're 3 sisters. One is a dermatologist in New York. The other one was a pediatrician / clinical trial doctor. And the pediatrician / clinical trial doctors did over 500 clinical trials for pharma, has brought a lot of drugs to market. Why was it that, pharma listened to us during all those clinical trials? Think about drugs like Remicade that made it to the market. Drugs like Repatha. I did the clinical trial on Repatha for cholesterol for Amgen. That went to market. Why are we listened to when we bring a drug to market, and we're not listened to when we're saying, hey guys, pay attention to the microbiome? I'm not here to shake the beehive of pharma. I'm here to take the beehive and put it in a nice place so it can make me some nice honey. That's what, because Rome, you're destroying the gut, you're destroying Rome. Rome was not built in one day, much like the gut's not going to be built in one day, and it was not built with one person. I'm not one person to restore the microbiome of humanity, but I'm one person that can be a little bit of a hurricane and work with multiple pharmaceutical companies like I've done in the past to say, let's start looking at the microbiome, guys, because eventually you're going to be that patient. And eventually you're going to come to me. How many executives from pharma have I treated as patients that have come to me because of my knowledge that I have of clinical trials? You know, how many billionaires have I treated? How many celebrities have I treated? I'm a Malibu physician, you know. I treat outside the box, I innovate, but I also look at what's out there in the clinical trial world that could help my patient. Because ultimately, if you stop the innovations, you stop progress, you stop healthcare. And it doesn't help the person, the executive at pharma, when he becomes the patient. Who is he going to go to? You've killed off everyone that was innovating. And you've given fear to every doctor. You know, I have the head of an academic center today that called me. Her kid has COVID. She's scared of giving ivermectin. She's like, am I going to lose my license if I write ivermectin? I'm like, you're a gastroenterologist. I mean, come on. We got to be better. We got to be more brave. The art of medicine needs to remain an art.
So when it comes to, you know, the art and perhaps of refloralization, I really like this term. It's a very nice term for something that maybe doesn't look as nice if you were to kind of staring at it. But you have had this case. I know that you're still working on publishing the research where you did this with twins, and we know that the twin studies are very popular for a bunch of reasons because the genetics are identical. What happened?
So from COVID and from doing that N of 1, which took time, and then from trying to get this familial FMT, I had these kids that were basically coming in with autism. And I have a lot of patients that come to me that have tried so many things. And so this case was 2 twins with the mom flew in from Tennessee, and I felt bad for her, and I basically innovated. But I said to her, I said, let me look at the microbiome. What was amazing about this case, and it's going to be a breakthrough, I don't want to say too much because it's going to be published in October at the American College of Gastro, but essentially we saw the identical, out of trillions of microbes, we saw elevation, relative abundance of microbes elevated, the same 3 phylum in both identical kids. And as we refloralized the gut, not with fecal transplant, but with methods, we basically noticed that those microbes disappeared and the good bacteria came on at the same time as speech started. So this was a breakthrough case, and it's going to be a breakthrough for the FDA once they see that, and we're going to use that. So we're going to start doing familial fecal transplant with the FDA, but we're hoping that we can bring this other method after, while we're doing familial fecal transplant to get the data to understand, because this could have been a fluke with these 2 kids, but we want to try to reproduce these 2 kids to see if we can do this for other kids. Mm-hmm. And therefore maybe run 2 protocols, one with familial FMT, fecal microbiota transplant or intestinal microbiota transplant, and then another one with this protocol to kind of see, can we do this more, safer, better, less playing with poop, because this doesn't play with poop.
Well, and the other aspect is also that, as we said at the beginning, everybody's different,
yes,
right?
Yes.
And so I think this is actually kind of important. There isn't a sort of one size fits all solution when it comes to this.
There isn't a microbiome. There's trillions of microbes, and like I gave you the example with the fungus, or it could be a fungal overgrowth. It could be even Dr. Feingold, who was the beginning, who basically said, let's try vancomycin, right? He said, let's try vancomycin for kids with autism. And he saw something with vancomycin. What he was seeing was a destruction of a microbiome and a suppression of microbes that secrete toxins, which decreased the aggressivity of the kid, but did not restore the speech. But at least it gave a quality of life to the family to say, hey, our kid is not banging his head on the wall. And so vancomycin got us to this level, right? But vancomycin is not a permanent solution. Vancomycin, wipes out the gut and puts you in a sterile and increases some microbes. But the solution is really to restore the gut to the way it was. And the challenge that we have is we do not know what it was before. So when you take a kid and he has a destroyed microbiome, you don't know what his fingerprint of his microbiome was before to reproduce him, right? It's kind of like destroying a house and you're trying to reproduce the house, but you don't know what it looked like. You don't have the floor plan, you don't have the architecture before that was done on it. So it's the same thing with a kid, and you're right, everybody's different, so everybody may not need the same, but we need to be more precise. What I would like to see in the field of the microbiome and with pharma is to get away from feces and to get into more precise work. In other words, this is a compounding of microbes that this person needs, right? I think that's what I'd like to see.
You know, something just kind of struck me though. If you're going to take some sort of therapy which is going to affect your gut biome, like for example, you mentioned antibiotics earlier. I don't know if it was obvious to people. You can basically nuke your gut if you use heavy antibiotics or protracted use of antibiotics. So this creates its own set of problems, like in some cases C. diff and so forth. Does it make sense to kind of, I don't know, put some on ice before you, if you do have to go into some sort of treatment, and then maybe that might be useful in the future?
So I do that with some patients that I see have a spectacular microbiome and are super healthy. I say, you may want to save it. You know, I saved some of mine before COVID because I knew I was going to be on the front line. I was going to be exposed to COVID, and I wanted to make sure I had my original microbiome that I could go back to because I know the genetics in my family. And I know I want to go back to my personality in a way and what I can do. So I kind of wanted that. But yes, that's the future. Again, there's red tape with that as well. You need to have a licensed lab. You need to store it properly. You need to make sure it's the right stools. You don't want to give someone, that's diseased a microbiome that was less than perfect. And you got to also say, well, that person got diseased. Is what they got was the beginning. Should I give them back the microbes that yes, they're taking antibiotics, but technically, if you take antibiotics, you're supposed to bounce back. So your microbiome is bouncing back. If you're not bouncing back, there might be a problem with that microbiome.
With the original.
Yeah, with the original. So, and it's very rare, by the way, and let me just say this to everyone. It's very difficult to find a perfect microbiome. It is very difficult because everybody's doing everything. You're drinking too much, you're killing your microbiome. Now, if you're lucky, it bounces back up and you become resilient and you can tolerate the alcohol. You apply a topical lotion that has some toxins in it that could destroy your microbiome as well. So everything we do affects the microbiome, and you count on your resilience to survive all those things. People got vaccinated and got injured, but people got vaccinated and didn't get injured. What's the difference between those people? A resilient microbiome is what's the difference. People that take antibiotics and get into C. diff. What's the difference with those people and the person that takes antibiotics and never gets C. diff? Resilience. So I think we need to look more carefully at the resilient factor of the microbiome, because that's what allows people to live on more than the presence or the absence of microbes. And like I said, there's trillions of microbes. Mm-hmm. We're just touching the surface. I'm telling you right now about C. diff. I'm telling you right now about bifidobacteria. But what about the other bugs? Whenever someone tells me, whenever there's always an arrogant physician that comes up like they know it all, right? And I always say to them, I go, what's Doria? Is that a good bug or is that a bad bug? What's Rosaburia? Is that a good microbe or a bad microbe? And then they're like, what? Out of left field. But that's the reality, right? The expression, you don't know sh.t. Well, it does apply. You don't know the microbiome. If you don't know the microbiome and it's trillions of microbes, you got to stay humble in medicine, and you got to stay humble as a human, because there's trillions of microbes out there. And if you start killing them groups by groups, eventually you kill the human. The microbiome, to me, is a look at humanity, but at the microscopic world, right? You're looking at all these microbes, groups of microbes coming together to create a healthy human. You kill off the Clostridium, you kill off the Bifidobacteria, you kill off the Firmicutes, that human's no longer able to metabolize sugar or to metabolize calcium. Their mitochondria are dead, they're non-functional. So the microbiome, the balance of the microbiome directs that human, because we're just a reservoir. When you go to Venezuela and you have a population that has Giardia in their guts, right? An American goes to Venezuela, gets Giardia, will get diarrhea. A person in Venezuela that is living in that environment with Giardia, they're fine, they're resilient. The African microbiome is different than the Amazon jungle, than the Amish population in America. So what do all these microbial communities do? There's different regions, and they basically all work the planet. The microbiome underneath the ground of the planet survived thanks to this diversity all around. So you have to look at your, and I always tell my patients, a phylum. What is a phylum? It's a group of microbes that share one thing in common. If you look at the African community, if you look at the Amazon jungle, they have a lot of phyla, a lot of groups of microbes that share one thing in common. Americans barely have 3 or 4. Now we are globalizing the world with our American ways, and we're making Africa look like America. So are we going to decrease those phyla in Africa and therefore mimic America? And now we've lost groups of microbes that were supposed to sustain that, African community. I'll take it one step further. You take a person from the Amazon jungle that lives in the jungle. They've adapted to the Amazon. They've adapted to the jungle. I will go to the jungle probably because I live in this sterile environment. I'll get sick because I've not seen these microbes in my life. But now you start giving foods from America to the Amazon jungle. Guess what's going to happen? You're going to weaken the Amazon jungle, and they're not going to be able to survive in their own environment. Now the microbiome of these Amazonians is going to change in the Amazon. The culture, the fruits, the vegetation is now changing because you've kind of made it the same as the microbiome of America. So my interest with the microbiome is not just, hey, let's fix autism, let's showcase, Parkinson's signature microbiome, let's showcase Alzheimer's. My interest is really preserving the microbiome of humanity, to say, hey, Japan looks like this, China looks like this, Mexico looks like this, because that diversity needs to remain.
But I also think the headline here, right, the thing that you're not mentioning is that all those conditions are actually treatable by affecting the microbiome, and that's been shown, right? And I don't know if everybody understands that. Not every person and not every time.
So here's the thing. When you say that, it gets the academia to go, oh my God, she's talking cures, etc. You can't really say that until you show the data, right? We have anecdotal data that shows, if you look at the studies from China, they've showed improvement of Parkinson's with fecal microbiota transplant. Johns Hopkins is going to start a study on that, right? So we're at the beginning of all this. Eventually we'll go back and say, oh my God, how archaic these humans were. They were practicing, they were operating on a kidney instead of changing the microbiome, right? I mean, we're in the Star Trek era right now. I don't know if you saw that episode of Star Trek where, the doctor gives a pill and he goes to a patient, he goes, kidney dialysis? How barbaric. Here, take this pill and call me in the morning. That's going to be the future. We're not there yet. I mean, it took 62 years to get C. diff into the guidelines as fecal transplant. I think that's what I'd like to see. But right now, we need to kind of bring humanity to us for them to listen so that we can advance and move forward. So we can't really say things like, well, there is cures and this and that, because we're shutting off the academia, the academic doctor who is basically, within the box of, I need this, this, and this for you to prove me that I need to pay attention to your experiment, right? Because we all have that gut feeling that says, hey, look at this study. It validates what I said. I improve, I give raw milk or whatever, and my gut is improved. But the raw milk could also have, to the mind of a physician at Harvard, for example, he'll say, but wait a minute, raw milk has a lot of other microbes that this person could affect that person. Right? Because you're dealing with a population that is, in a way, immunosuppressed, lacking microbes, and now you're giving them a diverse, product that could be, clean, could not be clean, depends on the practices of the farm that you went to. So, there's a lot of work that needs to be done. That's all I'm going to say.
Another thing, but I guess we should say that there's potential in all these areas.
100%,
Very real,
yes,
real potential.
Yes,
right. And that's actually that's what I meant. This certainly is not something that's being broadly done or explored. Right. I understand. But the other thing that you mentioned, which I thought was really interesting, was I think you were suggesting that when your gut flora changes significantly, your personality might change significantly. I think you mentioned that, like you alluded to that a few times.
Yes. So
as we've been talking.
Yeah. So we showed data of a signature microbiome in anxiety. Remember, people were very anxious during COVID, and whether it was from the media, whether it was from whatever, the COVID itself or the treatment, people were very anxious with COVID. And what we noticed with COVID was essentially people, because they were anxious, we were able to test our microbiome, and we were able to see a signature microbiome with anxiety. We gave a questionnaire, which is a GAD score.
Can I just jump in for a sec? When you say you saw signature, there were some commonalities in microbiome with everybody who was exhibiting anxiety.
So we gave people...
That's what you understand?
That's what I'm saying. We gave people a questionnaire. I worked with Dr. Sasha Bistritsky from UCLA. And basically, we gave a questionnaire, which was a GAD questionnaire. It's an anxiety score. You basically check the box, like, are you sleeping, 1 to 5, best or not. And you get a score at the end. And then depending on the score, the score dictates your anxiety level. What we noticed is that there was a huge correlation with a score that determines anxiety on the GAD questionnaire with a certain microbiome picture. And so we said, well, you know what, maybe this is how people that have anxiety. One of the key feature with anxiety was this loss of bifidobacteria. We then took the study to another level in bipolars. We said, let's look at bipolar disorders. And again, an absence of certain microbes, an increase in certain microbes gave us this signature, kind of like a formula. AB is elevated, CD is down. So how do we bring back C and D? How do we bring...
Because the hypothesis is that if you fix that, you can help with the problem.
That's the hypothesis, right? And that's exactly where I want to get pharma to say, hey, this is a hypothesis. Let's test this out and give the opposite formula, right? And so what we did is we started looking at that for bipolar disorder, anxiety. Why? Because when you talk to doctors who do fecal transplant, they will tell you, I had a case with a guy was suicidal, super anxious, suicidal, psoriasis, C. diff, chronic UTI, and basically I gave him fecal transplant from a stool bank from Dr. Alex Kurutz. By the way, Alex has done some amazing work in the world of, and I want to acknowledge all these doctors because we wouldn't be at the microbiome level without the work of all these doctors. And Alex Kurutz basically, had a stool bank, and he gave me a stool from the stool bank for this patient. I had tried giving him his wife's poop in the beginning as a transplant. It didn't work. And then I gave him this donor from Alex Kurutz's lab and University of Minnesota, and basically the patient's suicidal ideation disappeared, chronic UTI disappeared, psoriasis disappeared, C. diff disappeared. And to me, this case, I've yet to see the patient. It's been 5 years. He's doing amazing. And we showed engraftment with that case. In other words, it latched onto those
microbes. Stuck. Right,
it stuck,
right.
And it persisted in sticking, right? In fact, I said to him, I said, don't ever go to Minnesota because there's someone that's matching you better than your wife. But that's like a side joke. But Alex Carruth's essentially, that was a case that we discovered. The right donor can change the mental status. The right donor can change the suicidal ideation, you know? And so whatever
how was the donor chosen in this case?
It was just serendipitous. It was really serendipitous. That's how research happens, you know, serendipitously. You know, like I said, I picked the wife as a donor to begin with. Turned out he kept having C. diff. And by the way, this was a very interesting case for multiple levels. One, he had diarrhea, but we kept testing him at the lab with the conventional test that we have for C. diff. And we kept finding he was negative, negative, negative. We never could prove he had C. diff. And finally, when I did, you know, genetic sequencing of the gut and I saw it, I said, I got to keep doing these, you know, lab tests from the conventional lab because that's what proves that he has C. diff. It took me 11 stool samples to prove that he had C. diff. On the 11th one, he finally had C. diff. I treated him for C. diff conventional, it didn't succeed. He kept having diarrhea. And then we started considering, you know, we treated him twice. And then we started considering the wife as a donor for C. diff. And that didn't work. So then that's when I called Alex and I said, can I have some stools? Well, you can't do that anymore because it's all kind of regulated. And Alex is doing his own work with Dr. Adams on autism. So, you know, back then it was much easier to just call a physician that had a stool bank and say, hey, can you get me the best stool donor? And why I like that and physician is because he's taking the history. He's getting from the history. You know, the worst mistake we do is taking stools from a person we think is healthy, but really that person is not healthy. You come to find out the person was an alcoholic. The person is a druggie. The person is bipolar, you know, didn't tell you. So history taking of donors is very important, and that's an art on its own.
How do you determine, this is, given everything you've just said about diversity
Yes.
and so forth, it also sounds like you've been on this quest to find the perfect
Yes.
microbiome, or that actually exists as a
Yes.
concept. So what is that? Like,
It's not defined yet. It's not something, there's all these lab tests out there, stool tests that tell you, oh, you have this microbes, and people kind of like, you know, put their money on these stool tests. And when you look at these stool tests, and actually it was a study from Scott Jackson showed that these stool tests are not validated. They're not reproducible. You know, different labs show different, and I even tested myself these labs, right? Because I would have never opened Progenobiome if there was a lab out there that could give me valid, verified, reproducible data. You want to make sure that when you test your stool sample, you get the same data. If I show one day you have acromencia in your stool, like 10% elevation of acromencia, you want to retest the same stool sample in a different lab, and you want to show the 10% acromencia. If you show that one lab is giving you acromencia, but another lab you have elevated bacteroides, that's not valid. That's not reproducible, right? So when people come to me and they say, well, doctor, I have 0 bifidobacteria. How do you know? Well, I tested. Well, how do you know what they tested? At what level of depth of the microbiome did they test? And did they test your food that you ate last night? Or are they testing your baseline of your microbiome? So there's multifactorial reasons why the testing itself needs to be perfect in order to get that reproducibility of that data. What I showed with, the vaccines before and after, you have to have a validated reproducible assay to do that, right? Because otherwise you can't really show the data. If one day you have acromencia that's high, one day you have bifidobacteria, one day you don't have bifidobacteria. I mean, you gotta have some kind of way of knowing, and there's different pipelines that we do when we analyze the stools to see what's elevated, what's really elevated, and we retest, right? So, because we have to reproduce the data. So when you look at that and you look at the stools and you kind of say, what's going on there? What is the perfect microbiome, right? You're not going to understand these microbes unless you try to remove these microbes and see if you change the disease. With autism, for example, Dr. Feingold, who wrote the book on anaerobic infections, basically started with the idea Clostridium perfringens is the bacteria behind autism. Then he said, no, wait, there's the Sulfovibrio is the bacteria. Somebody else comes along and says, no, it's this other microbe. So is it the Sulfovibrio? Is it Clostridium perfringens? I found Lactobacillus animalis was elevated, my kid with autism, right? I found Bacteroides plebeius. Is it? Is it one micro? So here we are all different. And here we are, every disease has a different microbe that causes that predisposition. Why? That's where we need to be. So how do you understand what is a perfect microbiome? You can't really. You're practicing the art of medicine. You're practicing taking a history from the patient and saying, let me find clues of what you did that got me here. It's playing detective, right? It's like finding the murderer, who was the murderer at the end, right? You're trying to find the bug that caused the problem in a trillion. So it's like a needle in a haystack. And then you're trying to remove that needle gently without disrupting the haystack, right? So that's where we are in the microbiome. We can't really say, this is a perfect microbiome. We can guess of what a perfect balance should be, could be.
I see.
But right now you're kind of following my hunch.
You're taking from people who, for all intents and purposes, are really healthy.
After taking a history
yeah.
and doing questionnaires that basically say, okay, this person's not anxious. If a person is anxious, that person is not qualified for a microbiome to be a donor, okay? If a person is bipolar, they don't qualify. If they have anything whatsoever, if they're taking medications, they do not qualify. So figure out who is the person that's not taking medicine, that doesn't drink alcohol, that is not bipolar, that is not depressed, that is not anxious. You know, it's very difficult. Those people are kind of that needle in the haystack. But people are desperate. You know, they listen to these interviews and, you know, like COVID, you know, those were desperate times. They listened to all these doctors out there and they were trying all sorts of things to save themselves. So it's very important to realize when we get into it's one thing to take ivermectin, for example. It's another thing to do stools and transfer stools, because unfortunately, majority of people will not find the perfect microbiome. And the majority of people will find a microbiome that probably may not be compatible with them. That's another problem. So, you know,
I think even if you have, you know, very closely genetic matched people,
maybe, but there's so many. Here's the thing: microbes. You know, the person that is resilient, do they have microbes that are secreting toxins that could harm the person that is not? When we pick donors, we do a whole slew of blood work and stool test, especially stool test. There are 3 tests that the FDA requires us to do, because there were 2 cases. I mean, obviously there's been thousands and thousands of fecal transplants done out there, but there's been 2 cases where people died, you know, and so unfortunately you have to kind of like put your guards on when that happens. You have to go back and say, wait a minute, I don't want that on my shift, right? Look, I compare fecal transplant or intestinal microbiota transplant to blood transfusion. And here's the thing, before we did blood transfusion, we didn't even have a CBC or a hemoglobin. We didn't know what we were looking at. People remember the days of George Washington. They would fix a virus by removing the blood of George Washington. I think that's probably what killed him, because they removed so much blood from him during a virus when that was not the way to do it, right? So they had no idea back then what a CBC was. They had no idea what a hemoglobin was. They had no idea that a hemoglobin below 7 you have to transfuse, but a hemoglobin above 7 you don't need to transfuse. You just need to, you know, give iron and good nutrition to the patient, right? It's the same thing with fecal transplant. We don't even have a marker. Now, is the bifidobacteria a marker? Is the Bacteroides a marker? We don't know yet. We need to do those studies to say, does the bifidobacteria correlate with this disease, this disease, this disease? And now we have a marker. Once you have a marker in the microbiome that you can like say, okay, let's look at these microbes. They seem to be out of whack. Let's try to fix them. Then you can start saying, okay, well, I need these microbes to offset these microbes that are missing. And then from there, you have to kind of look at the stools and say, well, this one would not fit with this one because this one has a bacteria that's toxic that could kill this one, right? So it's, again, the same principle as blood. You're not going to give a blood transfusion if you don't test for hepatitis C or HIV, right? Because we've learned that if you give blood to hemophiliacs, when we gave blood to hemophiliacs, they got hepatitis C, but we didn't know then, right? So this is why you don't stop research. You keep looking for answers over and over again. At the microbiome space, we're very early. We're 10 miles out of hundreds, you know? This is not of my lifetime. This is going to be of, you know, hundreds of years, probably. Of course, with AI, we may be speeding it up, but, you know, AI has its own little problems. So we got to be careful with AI as well.
So there seems to be, you know, quite a bit of open-minded thinking around health, especially preventative medicine, but of course in treatment of all sorts. And there's this huge focus on autism right now. You know, what would be your recommendations in terms of, you know, approaching the autism question through the biome, for example, or more broadly?
I mean, this is something that I'd love to work with this, you know, this government to kind of start seeing, and not only this government, but probably with governments from around the world as well, because autism, like I said, affects everyone. Every country has kids with autism. If we could come together to help these kids, what a great thing that would be. You know, I think it is. I think this is the right time to start that focus. I think what COVID did is it removed our trust in the agencies, removed our trust in the government, removed our trust from pharmaceutical companies. I think I'm the right person to kind of bring it all together to say, look, you want me to trust you, then let's start doing the research properly, where we look at the microbiome, where we understand these diseases properly, where we work together. You know, the guidelines of that drive research are ICH GCP guidelines. They were created not just for America, they were created around the world. So we all have, as clinical trials doctor, we come together with doctors around the world. Part of the reason that I stepped into the pandemic was because I knew I had colleagues in Italy that were doing clinical trials. I had colleagues in Germany that were doing clinical trials. I could call Italy and say, what's been working for you? And then I could apply it for my patients and my population here in America. I think the same way that research joins all of us, we need to start joining together to understand and to fix these kids. Because here's the big problem. 1 in 12.5 boys in California have autism. When are we going to start paying attention? When 1 in 1 kid is autistic? And if not now, when? We need to start now in order for our kids and our children to survive, because our children is our future. And the only way to fix that is to all come together as human beings for the goodness of our children and the generations in the future.
Well, Dr. Sabine Hazan, it's such a pleasure to have had you on.
Thank you, and thank you again for having me.
Thank you all for joining Dr. Sabine Hazan and me on this episode of American Thought Leaders. I'm your host, Jan Jekielek.